Hi, welcome to the game of harmony. So let us start with tic-tac-toe. We all know this game. So if I decide to move fast, the game begins, game is running, so it's yellow. I put in the middle and computer puts here. One who makes three in a line wins. I have to put here. I have to, it doesn't matter, it's a draw. And if I go second, it's a nice game, the game of tic-tac-toe. But the problem is most of the times it's a draw. If two experts play, it is definitely to be a draw. So people improve this game. They call it no tacto. It's the literature the reference is available in Wikipedia in this name no tacto. Here only one symbol is used, and one who makes three in a line first loses. Okay, one who makes three in a line loses. So one who makes the first three in a line loses. So I start here. So I cannot put here. It will be three in a line. See, if I put here, it's red. I lose. Okay. So I put here. Then I put here. Then if I put here, the computer has no other option but to make three in a line. So the computer loses. Okay. So I win. It's called no tacto. So if I move second, see, this time I'll be winning against computer. I put here, and computer has to make three in a line, so I win. Now this game of no tacto, I can play it in a 3 by 3 board. Okay, so I move first. The computer is thinking. So one who makes three in a line loses. So this this is my turn red. This is computer's choice black, and this square 2 1 square gets blocked because you cannot put here because it will make three in a line. So one who makes the last move wins. Okay, so I make the last move. Everything else is blocked. So it's green for me. Now this is in 3 by 3 board. Now I can let me see if I what happens if I go move second. So computer puts here, I put here, computer puts here, I put here. So I win. So I win both when moved I moved first as well as when I moved second. So this can be played in bigger boards, a board of 4 by 4. I think I can win the 4 by 4 game also. The computer is thinking. Okay. Now if I put here, there is nowhere for the computer to make its choice, so I win. So I win. It's green for me. So if I go second, see, this is the last move for me and there is no other option, so I win. Sometimes I have won the 5 by 5 board, so if I move first, oh, I'm going to lose. I'm going to lose. Mm, I'm good. Maybe no. See, see, only two squares left. So computer wins and I lose. Now, this can be played in larger boards, up to 10 by 10 board. The computer thinks only last 10 moves. I'm not going to play it. It will take time. And more than that, you can fix how many how many consecutive you allow. So if in case of four, you can allow three consecutive, at most three consecutive, three adjacent squares to be chosen. Hmm. So I lose. So it can be played in say 10 by 10 board with say nine maximum adjacent in the board. Okay. Now this is to be played by the couple. I mean, you can play against a friend in a piece of paper, or you can play against a computer. Now it can be played in a solitary mode also. The goal is to maximize the number of squares occupied. So in a 4 by 4 board with two maximum consecutive allowed, I can go up to 9. So let me number them. So I could occupy four box, 9 boxes in a 4 by 4 grid, and that's the maximum possible. Now you can try up to 10 10 by 10 grid, how much is possible, which say three maximum consecutive allowed, three maximum adjacent allowed. So let me try randomly. Some squares are getting blocked because you won't be allowed to put more than three. At most three, five, six, seven are adjacent, three of them. So this is blocked. You cannot put here. You cannot put here. So this way, how much you can score? I have scored up to 24, 25. 40. So I could go up to 58, and you can challenge your friend to cross 58. Now, with two maximum consecutive allowed, I could go up to 51. One of my friends from Bengali friend, Facebook friend from France sent me solutions of 52, but I don't know what is the maximum. This is analysis board. You can do a simulation. Say I can do a simulation for 10 by 10 board with maximum consecutive 2. I can do a simulation and see what are the possible values. Now, this is analysis board. You have options to run all possible cases, but I could not run it in six. So in 6 by 6 board, it's hanging. The computer is hanging. It's so enormous in number. Computer is hanging. I could solve a 3, 4, 5, 3 by 3 board, 4 by 4 board, 5 by 5 board. I could run all possible cases and do all distinctive results. So it's randomly creating 100 results, and it will give us the counts. How many are one, how many are nine, how many are uh, in the range. So it's 100% complete. I'm not I'm not going to see the designs. And the numbers range from, I mean, there are 2% cases which stopped at 42. There is only 1% case which stopped at 49, and these are the maximum stopped at 45 out of 100. This is sort of study one can do. One can search certain number. So this is the template which one can take a printout and play with friends in a 10 by 10 board, or you can play in smaller boards also. These things can be marketed maybe as a game. Now here is a lot of theory. I could find that harmony number in 3 by 3 board with two maximum adjacent allowed is 6. You can go at most up to 6 for 3 by 3 board. For 4 by 4 board, you can go up to 9 when the maximum number allowed is 2. For 4 by 4 board, you can go up to 12 when the maximum number allowed is 3. Similarly, 5, 2 is 16, 5, harmony 5, 3 is 18, harmony 5, 4 is 20. In general, sorry, harmony Mn is the maximum value of k, where k can be colored squares in a m by m square grid with no more than n consecutive color square in a line, row, column, or diagonal. Here are two solutions of 52 that was sent by my Bengali friend from France. I could prove that harmony 10 to is less than or equal to 70, but as per my friend, 53 is impossible, but I haven't got any proof yet. Thank you.